Welcome to the Deep Dive, where we take a stack of information and really extract the most important nuggets of knowledge and insight for you, our listener.
That's the goal.
Today, we are plunging deep into what you might call the invisible engine of our digital world, data centers.
hmm
But this isn't just about rows of blinking lights, is it? It's a story of incredible growth, really cutting-edge technology, and, well, a fascinating geopolitical chess match playing out right now.
Indeed. And we're specifically looking at the rapid, almost explosive surge in data center development across Southeast Asia.
Right.
This isn't just, an economic or technological shift just for that region, although it's huge for them.
Yeah. Significant in itself.
Exactly, but it has these far-reaching implications that ripple across global supply chains, strategic power dynamics, the whole picture.
Absolutely. So our mission today, our deep dive, is really to explore how this remarkable boom in Southeast Asia isn't just about its own digital economy growing,
Which it is, of course.
which it definitely is, but how it's intricately woven into the, well, intensifying global AI competition.
hmm The U.S.-China dynamic looms large here.
Exactly, particularly that high-stakes rivalry between the U.S. and China. We'll examine the sheer scale of this expansion, look at the bleeding-edge technologies powering it, and, try to understand the complex geopolitical chessboard it's being played on.
It's a truly fascinating convergence.
Yeah.
You've got local ambition meeting global strategy head-on.
It really is.
And to help illuminate this, our deep dive is built on a pretty diverse collection of sources. We've pulled insights from leading tech journals, the ones tracking the latest innovations,
Okay.
financial news outlets, obviously revealing the massive investments flowing in.
Right, following the money.
Always follow the money. And also comprehensive regional reports that give us that granular, on-the-ground data.
So a multifaceted view.
Exactly. It's essential, really, to grasp the nuances of this whole evolving landscape.
Okay, let's get into it. The sheer velocity, the speed of this digital transformation in Southeast Asia is just, it's astonishing.
It really is.
Let's start with the fundamental numbers, maybe, just to illustrate the incredible scale of this boom. Because Southeast Asia is experiencing, well, nothing short of a massive surge in data center capacity.
Massive is the right word.
It's a region that's rapidly asserting itself in the digital landscape.
Yeah, the numbers really underscore the ambition, but also the journey they're on. Currently, if you look at it, Southeast Asia still lags a bit relative to global averages in data center capacity.
Okay, so there's room to grow.
A lot of room. We're looking at only about 1.8 megawatts MW per million population,
Right.
which, tells you there's significant headroom compared to, say, more established digital hubs like Northern Virginia or Frankfurt.
Sure.
But that is changing dramatically and quickly. Projections show nearly a threefold growth by 2027.
Threefold.
Yeah, with an additional 200 million rook of capacity expected over just the next 4 years.
2,100 megawatts? That's hard to picture.
It is. Think of it like enough power for a city of millions, but solely dedicated to digital processing.
Right.
So this isn't just about playing catch-up. It's a strong, fundamental driver for third-party business models. Everything from cloud services to specialized AI compute. And it's fueling broader regional economic development at the same time. It's an immense amount of new infrastructure coming online.
That's a staggering amount of power and capacity in such a short time frame. And we're seeing this play out in some truly ambitious, even groundbreaking projects on the ground, right?
Absolutely. You can point to specific examples.
Are there any particular ones that really stand out, maybe in terms of their scale or their innovative approach?
Yeah, definitely. The Philippines is a prime example of this aggressive expansion and innovation. They've launched what they're calling the country's first GPU-powered, AI-first hyperscale data center.
AI first. Okay.
Yeah, exactly. It's PLDT's Via Trio Rosa, or
Yeah.
VSR. And this isn't just, a big server room. It's designed as an industrial-grade facility, massive in scale. The kind that powers global cloud providers and cutting-edge AI operations.
And it's already running.
Yep, operational since July 2024. Already boasting a substantial 50 MW capacity.
50 megawatts is already pretty big.
It is. But what's truly remarkable about VSR is PLDT's plan, their ambition, to expand that capacity to an astounding 500 milliW.
500. Okay, that's a huge jump.
It's a massive statement of intent. When you consider 50 milliW is already enough to power a small town.
Right.
0.500 milliW aims squarely at positioning the Philippines not just as a domestic digital leader, but as a major regional digital hub, ready to compete globally. Precisely. And it's not just about the raw power, the megawatts. VSR also offers something called GPU as a service, or GPUATI,
It's GPUAS.
powered by none other than NVIDIA, of course.
Oh, naturally.
And this is a crucial offering. Imagine businesses, maybe small startups or even large enterprises, needing access to immense AI computing power.
For training models, complex analysis.
Exactly. Developing advanced machine learning models,
Mhm.
but they don't have the massive upfront capital to build their own GPU farms.
Right. Which is prohibitive for most.
Totally.
Yeah.
So GPUAS lets them essentially rent that power. This is designed specifically to accelerate digital transformation across vital sectors: banking, healthcare, logistics, fintech, even government services.
By making that high-end compute more accessible.
Exactly. It lowers the barrier to entry for advanced AI significantly.
The connectivity must be absolutely critical too, right? To attract those international clients, the big cloud providers.
Oh, absolutely key. You can't be a hub without the connections. VSR is linked via major subsea cables, think Jupiter, the Asia Direct cable,
Okay.
and the upcoming Apricot cable. These are the fiber optic superhighways of the internet,
Got it.
ensuring low latency, high bandwidth to major global markets. Plus, it's got a carrier-neutral architecture,
Meaning?
meaning any telco provider can connect. It offers clients choice, prevents lock-in to a single network, and builds in resiliency.
Network diversity. Makes sense.
All of this makes it incredibly attractive to those global cloud players and large enterprises looking for reliable, high-performance digital infrastructure in the region.
And it's definitely not just the Philippines making these big moves. Indonesia, massive population, booming digital economy. They're expanding rapidly too, aren't they?
Indeed, they are. ST Telemedia Global Data Centers, or STT-GDC, they're a significant player globally.
Right. I know the name.
They recently broke ground on their third Indonesian data center in Jakarta, and at the same time topped out their second one. So, rapid progress.
And these aren't small facilities either, I assume.
Not at all. Both these new STT-GDC facilities are strategically located within the Greenland International Industrial Center, GIC, in Bekasi, West Java. It's becoming a real digital hub area.
Okay.
Each facility will support an impressive IT load of 24 millW when fully operational.
24 each.
Yeah. And when the whole campus is complete, it spans 4 buildings. It'll provide over 90 millW of total capacity.
90 megawatt.
And it's all powered by its own dedicated 150 kilovolt substation.
Wow, that's serious power infrastructure.
It really is. That kind of heavy-duty power is usually reserved for major industrial zones. It just signals the massive, always-on energy appetite of these facilities.
And who's behind this one? Is it local, international?
It's a joint venture, actually. It involves Indonesia's Tributra Group and Singapore's big investment firm Temasek,
Ah, Temasek. Okay.
which is STT GDC's parent company. So it really highlights that blend of regional know-how and international capital driving this growth.
So we've talked about the incredible scale, these huge projects, but let's unpack the why. What are the underlying currents, the core factors really fueling this immense data center expansion across Southeast Asia? What's driving this, well, insatiable demand?
Well, at its heart, I mean, the most fundamental driver is just robust digitalization trends across the board.
Right. Everything going online.
Everything.
Yeah.
And increasing cloud adoption across every facet of life and business. Consumers are relying more and more on digital services for everything: shopping, banking, entertainment.
Mm-hmm.
And businesses are migrating their operations to the cloud for efficiency, for scalability. This fundamental shift just creates this baseline, insatiable demand for data storage, processing power, and connectivity.
And you can really see that in just the daily habits of people across the region, can't you? The immense popularity of mobile services, for instance.
Oh, absolutely. Mobile is huge.
Mobile apps often feel like the default, or sometimes even the only way to do essential tasks. Booking a ride, paying for dinner, banking.
Yeah, it's often mobile first, sometimes mobile only. This contributes to a very high level of digital readiness across the population. They're comfortable, they expect it.
Right.
Thailand's telco sector is the great example. They're projecting, what, 3 to 5% annual growth in mobile service revenue? And that's underpinned by their high digital readiness and ongoing network modernization. We even see companies like SimLocal expanding into Thailand with eSIM tech.
Ah, for tourists mainly.
Exactly, specifically catering to that growing influx of foreign tourists who basically rely entirely on mobile connectivity from the moment they step off the plane. It really is a mobile-first digital experience for so many people there.
And another driver, maybe one that's a bit less obvious but still huge, is gaming, right?
Yes. The booming gaming market in Southeast Asia. It's not just entertainment, it's a massive economic force.
What kind of numbers are we talking?
Projections are for revenues hitting around USD 6.39 billion in 2025.
Wow, billion with a B.
Yep. And mobile gaming absolutely dominates. It accounted for something like 72% of the market in 2024.
72%.
Driven by, high smartphone availability, increasing internet penetration, and this translates directly into significant investments in digital infrastructure.
How so?
Well, over USD 30 billion has been allocated just for 5G networks across the region. And 5G fundamentally improves support for gaming technology. Faster speeds, lower latency, crucial for online multiplayer games.
Makes sense.
And then you layer AI on top of that. As AI advances, make games more adaptive, more personalized, visually stunning.
Like AI-powered characters, dynamic worlds.
Exactly. Real-time language translation in games even.
Huh.
All of that demands serious back-end computation power.
Which means more data centers needed.
Precisely. More demand for the powerful data processing capabilities that these data centers provide.
It really is this powerful, self-reinforcing cycle, isn't it? More mobile adoption fuels more gaming, more AI in gaming demands more data processing, and that drives the need for more data centers.
You got it.
And there's a critical geopolitical angle here too, isn't there? This idea of geopolitical shielding.
Yes, that's becoming increasingly important. Southeast Asia is perceived generally as being relatively shielded from some of the direct geopolitical risks stemming from the U.S.-China tensions. And that perception makes it an increasingly attractive destination for foreign investment, especially in critical digital infrastructure like data centers.
So it's not just a perception, it's almost like a calculated strategic advantage for the region.
Exactly. As these global tech giants try to navigate the complex and, frankly, increasingly fraught U.S.-China tech war, Southeast Asia emerges as this crucial, relatively neutral territory. It allows them to expand their digital footprint without being forced to pick a side or exposing themselves to direct economic or political crossfire from either Washington or Beijing.
It's like the Switzerland of data for the digital age.
That's a good way to put it. It's a unique insight, really, into how these high-stakes geopolitical games are directly shaping where physical infrastructure gets built.
Yeah.
And that stability, coupled with the inherent digital growth we've discussed, just makes it a very appealing environment for long-term strategic investment.
Okay, so we have the massive data centers themselves. But beyond the physical buildings and servers, there's this whole service ecosystem that springs up around them, right? To support the boom and keep everything running 24/7.
Absolutely. That ecosystem, the data center value chain, is incredibly extensive and complex.
Right.
It covers both the initial construction phase, designing and building these things, and crucially, the ongoing operational stages.
Keeping the lights on, literally.
Exactly. Both phases generate this continuous demand for a wide array of non-IT technical services. Think of it as everything needed to keep these colossal facilities running smoothly, safely, efficiently, way beyond just the servers and the network gear.
So what kind of services are we talking about specifically?
Well, you've got the initial design and build advisory,
All right.
making sure the facilities are optimized from day one for efficiency, for cooling, for future scalability.
Okay.
Then there's the absolutely vital ongoing maintenance. These are mission-critical facilities. Downtime is incredibly costly, sometimes catastrophic.
Can't afford for them to go down.
Never. And then specialized engineering support for all the complex electrical and cooling components, which, as we'll get into, is a colossal challenge, especially in tropical climates.
Yeah.
The sheet issues. Precisely. And then there's also data center information management, DCIM support, usually provided by software companies, with highly trained people managing these incredibly complex systems, tracking power usage, temperature, humidity, security access, everything.
Wow. Okay. Lots of moving parts.
Tons. And within this whole ecosystem, one area gaining significant prominence is third-party maintenance, or TPM.
TPM providers, what's their role?
Their value proposition is pretty immense, actually.
Right.
First, they offer economies of scale because they service multiple clients, multiple data centers.
Right.
Crucially, they usually have the expertise and the parts inventory to maintain assets from various different OEMs, original equipment manufacturers, and vendors.
So if a data center uses servers from Dell, storage from NetApp, networking from Cisco, the TPM can handle it all.
Often, yes. Which really simplifies operations for the data center operators, who almost always have a mix of hardware from different brands.
Makes sense. One point of contact.
Exactly. And they also bring global best practices to the region, drawing on experience from mature markets around the world. They're becoming a really crucial piece of ensuring operational efficiency and the longevity of these expensive facilities.
So what does the market look like for these supporting services? Is it dominated by a few big players, or is it more fragmented?
It's definitely more on the fragmented side and highly competitive.
Okay.
The market's populated by this diverse array of numerous small and mid-sized players. Often they operate within specific regional or national niches.
Local experts.
Yeah, and these local, smaller players often enjoy higher trust levels with clients because they really understand the local context, the regulations, the business culture, sometimes even the language nuances.
And maybe more flexibility.
Exactly. They can often offer greater flexibility and customization in their services, which is a big draw for many clients.
But what about the bigger international players?
They have their advantages too, of course.
Yeah.
They bring those global best practices we mentioned, offering a deeper pool of specialized expertise and usually more robust financial backing.
Right.
And they can foster stronger relationships with global or regional clients if they can offer a consistent service across multiple countries, a more unified, standardized approach.
So it's a mix.
Yeah.
Local agility versus global reach and standardization.
That's a good summary. It's a dynamic market with different providers catering to different needs.
Okay, this is fascinating. To really understand the cutting edge of this AI boom, though, we need to look beyond just the data center buildings themselves and dive into the tech powering them.
Right.
And while perhaps no company signals the future of AI quite like NVIDIA does,
They're certainly central to the conversation.
their recent GTC conference, I heard, offered some truly fascinating insights into where AI is headed and how it directly impacts the kind of infrastructure we're talking about, these massive data centers.
Yeah, GTC 2025 was truly one of the most jam-packed editions I can remember, just filled with announcements that are going to shape the AI landscape for years.
Like what? What were the big highlights?
Well, key among them was the unveiling of the world's first open humanoid robot platform, Isaac Geo's N1.
A humanoid robot.
Yeah, a major leap in advanced robotics. Then there was the latest NVIDIA Blackwell GPU,
Ah, the new chip.
the new chip, and it's a true beast, bringing a petaflop of AI power onto a single super chip.
A petaflop. That sounds immense.
It is. A petaflop is a quadrillion floating point operations per second. It's an incredible, almost incomprehensible leap in computing capability, all packed into one component.
Mind-boggling.
And they even teased a next-gen operating system on the horizon, hinting at these broader ecosystem developments that tie all these innovations together.
I kept hearing a lot about something called Omniverse coming out of GTC as well. It sounds incredibly ambitious. Can you maybe paint a picture for us of what NVIDIA is trying to achieve with that platform? Why is it so relevant?
NVIDIA's Omniverse.
Yeah.
Yeah, it's profoundly powerful and definitely highly ambitious. Think of it as like a portal for creating incredibly detailed, physically accurate virtual worlds.
Okay, like the metaverse, but more industrial.
Kind of, but much more focused on simulation and digital twins. It's designed to allow industries, think automakers, city planners, factory operators, to develop and operate complex, AI-enabled virtual environments.
So what can they do in these environments?
A lot. They can generate vast amounts of synthetic data for training their AI models. That's especially useful when real-world data is scarce, expensive, or maybe even dangerous to collect.
Right, like for autonomous driving.
Exactly. They can test autonomous vehicle software in safe, virtual settings that perfectly mirror real-world scenarios, complex intersections, bad weather, whatever, running millions of simulations in a fraction of the time it would take in the real world.
And digital twins.
And perhaps most transformative, they can build incredibly precise digital twins of entire factories or cities or even infrastructure like the data centers we're talking about.
For what purpose?
For optimization, for predictive maintenance, for complex what-if analysis. It's about creating these virtual worlds that not only mirror the real one, but allow you to optimize it, test it, and ultimately transform it.
And we're actually seeing this vision, this omniverse idea being applied right now, right? In Southeast Asia, you mentioned Twin Matrix earlier.
That's right. Twin Matrix is a fantastic example of this in action, founded and led by Eric Liu. They're tackling critical challenges in Southeast Asia's really rapidly urbanizing landscapes.
Where infrastructure struggles to keep up with city growth.
Precisely. Twin Matrix leverages these advanced map-based digital platforms that unify smart data silos, traffic data, energy usage, building sensors with geospatial layers.
Okay.
This creates a real-time conduit for editing, collaboration, interlayer analysis. essentially building highly interactive, highly accurate digital replicas of real places.
What's the benefit?
Well, this tech is expected to help measure and significantly reduce energy consumption, tackle decarbonization efforts, and vastly improve urban planning through these highly accurate simulation environments.
Is there a concrete example?
Absolutely. A
Yeah.
really impactful one is their creation of a spatial twin of Singapore's Changi Airport.
And Changi Airport. Okay.
And this wasn't just, a fancy 3D rendering. This digital twin actually helped reduce energy use across the massive facility. It improved navigation for millions of passengers. It enhanced IoT management and safety protocols.
And saved money.
And ultimately saved the airport millions in
Yeah.
operational costs. It's a clear, powerful demonstration of these omniverse-like capabilities delivering real-world value right in the heart of the region we're discussing.
And it sounds like the broader AI scene in the region is buzzing too. It's not just a few big projects.
Definitely not. Matan Libby's, who's the VP of Product at Scream, he specifically noted a strong turnout from Southeast Asian startups at GTC 2025.
Ah, interesting.
Reinforcing, as he put it, that the AI scene in the region is truly undeniably booming.
Which brings us back to NVIDIA's role in all this.
It absolutely is booming. And a major reason for that, and why GPC is so relevant to Southeast Asia, is NVIDIA's just pervasive presence and, frankly, undisputed market dominance empowering regional AI.
We hear so much about NVIDIA's GPUs, their graphics processing units. Are they really that integral, that indispensable to this whole AI ecosystem?
Overwhelmingly so, yes. NVIDIA's GPUs are widely considered the gold standard for powering AI applications, pretty much across the spectrum, from these massive data centers crunching petabytes of data down to the sophisticated algorithms in self-driving cars.
What kind of market share are we talking?
Estimates put it at around 80%, maybe even higher, market share in the GPU segment specifically for AI workloads.
80% plus.
Yeah.
Wow.
It makes them the default choice, the workhorse, for most high-performance AI computations. And then there's their CUDA software platform,
Right, the software side.
which creates this massive ecosystem that further locks in developers and researchers. It's hard to switch away once you're invested in CUDA.
And that market dominance has very real, tangible impacts on the ground in Southeast Asia, doesn't it?
Absolutely.
We saw earlier that the Philippines' Viaitaro Stasharo data center, that flagship project we talked about, is explicitly powered by NVIDIA GPU servers.
Yep. That's a direct example. And it's not just Southeast Asia benefiting or
Yeah.
relying on them. Deutsche Telekom, for instance, also tapped NVIDIA to build Europe's first industrial AI cloud.
Okay.
It just indicates NVIDIA's global reach and its critical, almost foundational role in AI infrastructure everywhere.
Now, you mentioned something earlier that was really intriguing about NVIDIA's revenue distribution in Singapore. Can you unpack that a bit more?
Yeah, it's a fascinating detail and something for you, our listener, to really consider. While NVIDIA's GPU sales registered in Singapore account for a significant chunk, 28% of its total global revenue.
28% is huge for one small country.
It's remarkable. But here's the kicker. Only 1% of the actual physical GPU units associated with that revenue are physically delivered to Singapore itself.
Only 1%. So where's the other 99% going?
Exactly. What does this imply about Singapore's role? It strongly suggests Singapore's acting as a key regional sales hub, maybe processing the financial transactions.
Right.
Or, perhaps more likely, it's acting as a crucial transshipment point for a much broader demand across Asia, or maybe even globally.
So the money flows through Singapore, but the chips go elsewhere.
Largely, yes. It indicates robust demand across the wider region, or even beyond, with the physical goods just flowing through Singapore as part of this complex global supply chain. It's a fascinating snapshot, really, of how value and physical goods can move in very distinct patterns in today's interconnected digital economy.
That is a truly thought-provoking detail about how these global supply chains actually operate. Now, shifting gears slightly, as this digital infrastructure boom continues at such a breakneck pace, especially in a tropical region like Southeast Asia, it brings with it some pretty significant environmental challenges. One of the most critical must be managing the immense heat generated by these data centers in constantly warm climates.
You're absolutely right. Heat management isn't just an efficiency issue, it's paramount, both for operational stability chips, don't like getting too hot, and for the environmental impact.
How much energy goes into cooling?
Estimates suggest about 0% of the total energy consumed in today's typical tropical data center is dedicated purely to cooling, often using traditional, energy-intensive liquid cooling methods.
40% just for cooling. Wow.
Yeah. It highlights this urgent, pressing need for more sustainable, more energy-efficient alternatives to mitigate the environmental footprint of all this rapid digital growth, especially in a region prone to high temperatures and high humidity year-round.
So what does this mean for sustainable operations? How do you reduce that massive environmental footprint? What cutting-edge innovations are being explored? It sounds like a problem requiring some truly inventive solutions.
It certainly is, and thankfully there's a lot of exciting research and development happening in this space. For instance, there's a dedicated testbed data center specifically designed for observation and experimentation with cooling technologies.
A cooling lab, essentially.
Pretty much. It features a symmetrically laid out data hall, so they can compare different cooling types side by side in real time under the same conditions.
And what are they finding?
The discoveries are quite promising, offering a glimpse into the future of data center cooling. For instance, advanced air-cooled systems have been shown to reduce the server heat load by up to 60%.
60% just with air.
Up to 60%, yeah, which is a massive potential energy saving right there.
Yeah.
And even when the primary liquid cooling system is turned off, basic air cooling can still remove about 60% of the heat, providing crucial redundancy and efficiency gains.
That's impressive for air cooling alone. But liquid cooling isn't being abandoned entirely, is it? It must have some inherent advantages, especially with densely packed, powerful chips like GPUs.
Exactly. While traditional liquid cooling accounts for a large chunk of energy use, it's also fundamentally a much more effective and targeted way of transferring heat away from those high-density, high-heat components compared to just blowing air across them. The testbed found that optimized liquid cooling systems can actually cut the overall energy use of the data center by 30%.
Cut energy use, even though it uses energy itself.
Yes, because it allows the chips to run cooler and therefore more efficiently. And that cooler operation can simultaneously boost the computing performance by a remarkable 40%.
Better performance and less energy overall. That's the goal.
That's the sweet spot. They're using state-of-the-art technologies, things like Meta's State Point Liquid Cooling Unit, which is a highly efficient, indirect evaporative cooling system.
Indirect evaporative cooling. How does that work in a humid climate?
Well, they're exploring these indirect techniques that significantly reduce the need for energy-hungry mechanical refrigeration, or chillers. They utilize cooler outside air when available, even if it's humid, often combined with desiccant-coated heat exchangers.
Desiccants to remove the moisture?
Exactly. They remove the moisture from the air before it's used for cooling. And even better, there are efforts now to recycle the waste heat generated from the liquid cooling loop itself, to regenerate those desiccant materials, drying them out so they can be used again. It creates a kind of circular energy economy within the data center.
Wow, that's clever, using waste heat productively.
It's a truly holistic, multi-pronged approach, combining advanced air cooling, optimized liquid cooling, smart use of outside air, moisture control, and heat recycling, all aimed at energy efficiency and sustainability.
And it seems the industry heavyweights are making increasingly public and ambitious commitments in this area, too.
They are. Google, for example, has publicly announced its goal to run all its data centers on carbon-free energy 24/7 by 2030.
24/7 carbon-free by 2030. That's ambitious.
Very ambitious. But it underscores the industry's growing commitment, or at least the stated commitment, and the seriousness with which they're approaching these sustainability challenges. Whether they can all meet those goals remains to be seen, but the direction is clear.
Okay, so we have this huge demand, incredible innovation in data centers and cooling. But beneath all of this, there's this crucial, almost foundational bottleneck we need to talk about. The sheer difficulty, the incredible precision required, and the absolutely astronomical cost of manufacturing the very GPUs, the chips that power this entire AI boom.
Yes, the supply-side constraints.
It makes you wonder, right? If the demand is so high and the profit margins are reportedly so lucrative, why can't they just make more? Why aren't new chip factories, new fabs popping up everywhere?
That's the multi-billion, maybe even trillion-dollar question everyone asks investors, gamers waiting for cards, AI companies.
Yeah.
And the answer is rooted in just immense, almost unimaginable difficulty and expense. There's a significant human resource and capital bottleneck, as the experts call it.
Meaning
you need both incredibly specialized, rare human expertise and vast amounts of capital to build these things. It limits the rate at which new factories or fabs can realistically be created.
Can you give us some figures? What kind of cost are we talking?
Easily tens of billions of dollars just to build one new silicon chip foundry from the ground up.
Tens of billions for one factory.
Yep. For example, TSMC, the world's leading contract chip manufacturer. They make chips for Apple, NVIDIA, AMD.
Right?
They announced an investment of $100 billion to build just 2 new foundries in the U.S., in Arizona.
100 billion for 2. Wow.
And even then, there are questions about whether these U.S.-based fabs will initially be using the absolute latest bleeding-edge process nodes that TSMC already has running in Taiwan.
So they might be slightly behind their home base fabs.
Potentially,
Yeah.
at least initially. TSMC is already producing advanced 3-nanometer chips in volume in Taiwan and is planning for 2-nanometer production to start there this year. Getting that capability running smoothly somewhere new takes time and, well, incredible skill.
So it's not just throwing money at it, it's this deep technical challenge. I've heard people informally call the fabrication process black magic. Is that just an exaggeration?
Honestly,
Yeah.
it really isn't that far off the mark. We're talking about manufacturing features at the nanometer scale in high-end chip fab.
How small is a nanometer, for context?
Okay, a human hair is about 80,000 to 100,000 nanometers thick. These chips have transistors and wires smaller than viruses.
Smaller than viruses, okay.
So the slightest vibration in the factory floor, a minuscule miscalibration of one of the hundreds of machines involved, or even a single microscopic dust particle invisible to the naked eye. Any of those can ruin entire batches of chips.
Destroying potentially millions of dollars in product.
Exactly. It drastically affects the yield, the percentage of good chips you get off each silicon wafer. This leads to what engineers often informally call a don't touch anything approach once a process is actually working well.
If it ain't broke, really don't fix it.
Precisely. The precision is so extraordinary that you can't just perfectly document what's working in Fab A and simply copy-paste the instructions to build Fab B somewhere else and expect it to work instantly.
It's more art than science sometimes.
It requires incredibly rare, highly specialized engineering expertise to install, tweak, maintain, and troubleshoot these hyper-complex processes. It makes scaling up production incredibly challenging, slow, and expensive. Even Intel, a giant in the field with decades of experience, has publicly struggled in recent years to consistently ramp up the latest and greatest fabs at the absolute bleeding edge.
And then there's ASML. They seem to occupy this absolutely unique, almost monopolistic position in the whole ecosystem. What makes them so critical?
They do indeed hold a unique position. ASML, a Dutch company, is the only company in the world capable of making the most advanced extreme ultraviolet or EUV lithography machines.
EUV lithography.
These machines are absolutely critical. They're the ones that use light to imprint the incredibly tiny circuit patterns onto the silicon wafers for these cutting-edge chips. No EUV, no sub-7 nanometer chips, basically.
And they're the only ones who can make them.
The only ones for the most advanced EUV needed for the leading nodes. And despite being the sole supplier for such vital technology, they can only produce a limited number, maybe 50 to 60 such machines per year.
50 or 60 globally per year. That sounds like a huge bottleneck.
It is a major bottleneck, and each one of these machines costs around $380 million.
Wow.
And they're enormous, the size of a double-decker bus, requiring their own dedicated building infrastructure. The technology inside is truly mind-boggling.
Like what?
It involves firing incredibly powerful lasers at microscopic droplets of molten tin thousands of times a second, creating a plasma that emits just the right wavelength of extreme ultraviolet light needed to etch those nanoscale patterns. It's an engineering marvel that almost defies easy description.
This sounds less like a single country's industry and more like a global symphony of highly specialized parts and processes where any weak link could bring the whole performance to a halt.
That is exactly what it is. It's a deeply, deeply interconnected global supply chain. And realistically, no single country, not the US, not China, not anyone, no matter how technologically advanced, can produce these 2-nanometer and under chips entirely from scratch using only domestic resources.
Who else is involved besides ASML?
You need Carl Zeiss, the German optics giant, for the incredibly precise mirrors and lenses inside the ASML machines. They have tolerances measured in picometers.
Okay.
You need specialized photoresist chemicals, often from Japanese companies, to actually etch the patterns onto the silicon. You need high-power lasers, often with American origins. Specialized tooling comes from various countries.
And the raw materials.
And the raw materials themselves. High-purity silicon often originates from places like China, Brazil, Russia. And neon gas, a crucial component for the lasers used in lithography. Historically, about 50% of the global supply of purified neon came from Ukraine.
Ukraine. Wow. So the war must have impacted that.
It certainly caused major concerns and price spikes initially, forcing diversification. It just highlights how the interdependence is staggering. making the entire supply chain incredibly complex and vulnerable to geopolitical shifts, natural disasters, or disruptions anywhere along the line.
Okay, so production is incredibly difficult, incredibly costly, and relies on this fragile global chain. Demand, especially for AI chips, is through the roof. So why then are consumer GPUs, the graphics cards gamers want, still relatively scarce sometimes and often very expensive? Is it purely a supply problem, or is there a deliberate strategy at play here?
It's a combination, but a big part of it comes down to market prioritization and the pure economics of the chip industry right now.
Meeting.
Meaning, while there's certainly high demand for gaming GPUs, the vast majority of the limited cutting-edge manufacturing capacity is being allocated to the much, much more profitable AI processors.
Ah, the data center chips.
Exactly. Those specialized AI chips, like NVIDIA's H100s or the newer Blackwell chips, can sell for $10,000, $20,000, maybe even $40,000 or more per unit, depending on the configuration and volume.
Compared to gaming GPUs.
Compared to high-end gaming GPUs, which typically sell for, what, $1,500, maybe $2,000 or less.
Big difference in profit margin.
Huge difference. For a company like NVIDIA, the gaming market, which used to be their core business, now accounts for only about 10–15% of its total revenue.
Only 10–15%.
Wow, the truly exponential profits, the massive growth, is all happening in the data center and AI space. The demand there is virtually insatiable right now, and the customers, big cloud providers, AI companies, have much higher price and elasticity. We need these chips, and we'll pay top dollar.
So it's not just about what the fabs can make, but what the chip designers like NVIDIA choose to prioritize making based on maximizing profitability. This idea of purposeful scarcity definitely comes to mind.
Indeed. It's arguably a calculated economic strategy. Manufacturers might deliberately produce less than the theoretical total market demand across all segments, specifically to keep prices high and maximize profit margins on the highest value products.
Why flood the market with lower margin gaming cards if you can sell every single high margin AI processor you can possibly make?
Exactly. We've seen reports, for example, suggesting NVIDIA is making an astounding profit margin, maybe even 1,000% on its H100 GPUs. While that exact number might be debated, the margins are undeniably massive.
Right.
And to circle back to that really intriguing detail about Singapore we discussed earlier,
Yeah.
the fact that 28% of NVIDIA's Singapore GPU sales revenue translates to only 1% of the actual units delivered to the country, it powerfully underscores this strategy. It signals these are very high-value transactions, almost certainly involving these premium, high-margin AI chips. Fewer physical units are moving through that specific point, but they represent enormous revenue, all optimized for maximum profitability in a supply-constrained environment. It's a masterclass in market leverage, really. Now, if we connect all this back to the bigger picture, the data center boom in Southeast Asia, the chip manufacturing complexities, NVIDIA's role, none of it can really be viewed in isolation from the escalating US-China AI competition.
Right, it's all intertwined.
Deeply. This competition is a crucial, defining aspect of what people are increasingly calling the AI war. It's fundamentally a struggle for technological supremacy that is going to shape the 21st century.
And it feels like these tensions are only intensifying, don't they? Particularly in critical areas like advanced technology chips, AI software, and also the minerals needed to make it all.
They absolutely are. We've seen how U.S. tech curbs, things like export controls on advanced chips and chip-making equipment, initially aimed at slowing China's progress, have, perhaps inadvertently, pushed China to innovate domestically at an astonishing pace out of necessity.
The Sputnik moment effect, maybe.
Something like that. It's led some analysts to speculate about the potential emergence of a super AI from unexpected sources, driven by this intense pressure and national focus on resilience and self-sufficiency.
And how do these U.S. policies or potential shifts in policy impact the calculations of Southeast Asian nations caught in the middle?
Significantly and complexly. Shifts in global policy approaches, whether it's rhetoric around America First, or the imposition of punitive tariffs, or even debates about aid cuts, or the conditions attached to things like the CHIPS Act subsidies.
Right.
All of this inevitably creates a sense of, well, unreliability or uncertainty for these nations. It forces them into complex crisis calculations about their alliances and dependencies.
Shaking relationships like the U.S.-ASEAN one.
It certainly can shake the foundations of long-standing relationships. Adding another layer of uncertainty around things like domestic subsidies for chip manufacturing, regardless of which U.S. administration is in power, inevitably sends ripples through global supply chains. It impacts investment decisions and strategic alliances in regions like Southeast Asia, who are trying to position themselves within this shifting landscape.
And beyond the direct tech policies, there are these broader economic shifts happening too, right, that further complicate the dynamic.
Absolutely. Things like fluctuations in the U.S. dollar's strength, for instance.
Yeah.
Some analysts see periods of dollar decline as handing China a golden opportunity to assert its economic influence through trade and investment denominated in yuan.
Okay.
And it's not just a U.S.-China story. Europe is also making very concerted moves to reduce its critical mineral dependence on China, seeking to diversify its own supply chains for things like rare earths needed for EVs and electronics.
De-risking, they call it.
De-risking, exactly. And the term overcapacity, particularly referring to Chinese manufacturing in areas like EVs and solar panels, has become this key economic buzzword, fueling trade tensions and clashes between Europe and China over industrial policies and market access. It's a truly multipolar economic chessboard, not just a bipolar one.
These shifts really highlight that dynamic, don't they? Where dependencies are being reevaluated everywhere and new alignments are being constantly considered.
Definitely. And despite all the U.S. restrictions, it's crucial not to underestimate the significant advancements China has made and continues to make in AI.
What are some concrete examples?
Well, we've seen Huawei, despite being under heavy restrictions, open its HarmonyOS 6 operating system to developers, complete with advanced AI features, building out its own ecosystem.
Right.
You have companies like Minimax developing AI reasoning models like M1, which rivals other leading models like DeepSeek, and is demonstrating remarkable efficiency, reportedly having the compute needed compared to rivals for certain tasks, while showing great proficiency in math and coding.
So more efficient models.
Exactly. China's Empyrean, which makes chip design software EDA tools,
Okay.
is seeing massive opportunities emerge precisely because of U.S. curbs on Western EDA software exports to China. They're filling a critical domestic gap.
And it's not just software, right? Hardware and robotics, too.
Definitely. Unitary Robotics, the Chinese company making those advanced humanoid robots and robot dogs you see in videos.
Yeah, they're impressive.
They've rapidly become a unicorn valued over $1 billion, securing substantial funding from major Chinese tech players like ByteDance, Alibaba, and Tencent.
Okay.
And, perhaps most impressively, demonstrating that independent innovation path. Chinese AI models like DeepSeek are being developed without any reliance on restricted NVIDIA chips, using alternative hardware solutions developed domestically or sourced elsewhere.
Driven by necessity again.
Driven by necessity, showcasing truly independent and resilient innovation. We've even seen, those widely shared videos demonstrating China's capabilities in advanced robotics, like that first ever humanoid robot kickboxing match. It showcases impressive dexterity, balance, and control systems.
These aren't minor tweaks. They're significant strides towards technological autonomy and leadership in key areas.
They really are.
So this raises an incredibly important question, maybe the central question for our listeners today. In this high-stakes global competition with these two tech titans, the U.S. and China, vying for supremacy, what is Southeast Asia's true role? Is it just a battleground where they compete? Is it a strategic partner to one side or the other? Or maybe something else entirely, a crucial swing region, maybe even a kingmaker in some respects?
It's complex, and I think the region represents immense, often overlooked potential in this global AI race. It's not just a passive playing field.
How much potential are we talking?
Well, some reports estimate it as a potential $50 billion AI boom opportunity for the region itself.
60 billion. Wow.
Yeah, an almost unimaginable figure just a few years ago. And the foundation is there. The region already boasts a surprisingly robust startup ecosystem. Over 2,000 AI startups have been identified.
2,000. How does that compare globally?
That's actually more than South Korea, and it nearly matches the numbers in established tech hubs like Japan and Germany.
Really? That's surprising.
It is. And Singapore in particular consistently ranks very high, often third in global AI indices. It scores exceptionally well in metrics like the number of AI scientists per million people, which is a critical indicator of future innovation potential.
The human capital.
Exactly. And the region's digital economy as a whole is just experiencing incredible growth, expanding in double digits annually in both revenue and profit across many sectors. It's a genuinely vibrant, dynamic environment for tech.
That sounds incredibly promising, almost like a sleeping giant finally awakening in the AI space. But what about the challenges? Surely it's not all smooth sailing for local AI startups trying to compete on this global stage, especially given how diverse the region is.
Oh, the challenges are significant, absolutely. The region's sheer diversity in language, culture, regulations, infrastructure levels significantly complicates the process of rapidly scaling products and services across borders.
Right. What works in Singapore might not work in Jakarta or Manila easily?
Precisely. Imagine trying to roll out an AI solution that needs to understand dozens of different languages and dialects, or navigate vastly different levels of internet connectivity, or deal with completely different data privacy regulations across 10 distinct countries.
That makes it much harder to create those large, unified data sets that AI models typically need to train effectively, doesn't it?
It does. It makes it much harder to achieve the economies of scale that AI solutions often rely on to become efficient and powerful. So the critical question really becomes, can these local tech companies profitably compete on the global stage? Or will they remain largely confined to their diverse, fragmented local markets?
And is there enough regional coordination?
That's another challenge. The divergence in national agendas and priorities among the different Southeast Asian countries makes it quite difficult to prioritize moonshot innovation on a coordinated regional scale.
What do you mean by moonshot innovation here?
Those really ambitious, transformative, often government-backed projects that require massive coordinated investment and a long-term unified vision, think like the original space race, or large-scale national AI strategies. Doing that across 10 different nations with different priorities is tough.
So, given those formidable hurdles, how can Southeast Asia navigate this? How can the region truly leverage its immense potential in this global AI arena? What are the strategic pathways to success?
Well, one strategic pathway often discussed is focusing on the earlier stages of the value chain. For example, the systematic collection, cleaning, and meticulous organization of unique big data sets relevant to the region or specific industries within it.
Why focus there?
Because that foundational data work can yield a significant, hard-to-replicate competitive advantage. If you have unique, well-structured data, you can train powerful AI models that others can't.
Is there an example of this working?
Yes, Singapore-based PatSnap is often cited as a prime example. They've apparently invested something like 17 years in building these vast, highly structured data sets covering patents, chemical structures, drug discovery information, food science data.
Oh, okay, very specialized.
Very specialized, very structured. And these unique data sets are now used to train their own highly specialized, sector-specific large language models. And their client list is impressive. Includes organizations like NASA, Tesla, Walt Disney Company. They build value on top of unique data curation.
So data as a moat. What else? Government support.
Government support is crucial too. Local governments across the region are stepping up, actively developing national AI frameworks and strategies. Singapore is particularly notable for actively funding numerous AI startups through various government initiatives and investment arms.
But it needs more than just startups and funding, right?
Absolutely. Crucially, success in this complex landscape requires a comprehensive ecosystem approach. It needs active collaboration and alignment between regulators, governments, the big corporate buyers of AI solutions, the innovative suppliers and startups, and ultimately the consumers who will adopt and use these technologies. It really takes a village, so to speak.
A coordinated effort from all sides.
Exactly.
And finally, how does the region position itself geopolitically amidst this intensifying U.S.-China rivalry? We've heard it described as hedging. What does that actually mean in practice for these countries?
Hedging is a good description. Southeast Asian countries are indeed often described as hedging ways out of troubled waters, particularly concerning sensitive issues like territorial disputes in the South China Sea, but also in the tech realm.
So not picking sides.
Essentially, yes.
Yeah.
It means they are actively and very carefully navigating the complex U.S.-China relationship, trying very hard to avoid being drawn exclusively into one superpower's orbit. They seek to maintain good diplomatic and economic relations with both Washington and Beijing.
Getting benefits from both sides.
Ideally, yes. Securing economic benefits, investment, and technological access from both sides, without overtly aligning militarily or technologically with either one in a way that antagonizes the other. China, for its part, is making concerted efforts to position itself as an attractive, reliable partner, an alternative, perhaps, to what some perceive as an unpredictable U.S., especially depending on the administration or specific policy shifts.
So it's a delicate, ongoing balancing act.
A very delicate, ongoing balancing act for these nations. They're constantly trying to maximize their strategic autonomy and national development prospects in an increasingly multipolar and contested world.
What a journey we've taken today. It's really covered a lot of ground. We've journeyed through the, well, explosive growth of data centers across Southeast Asia,
Hmm.
seeing how this infrastructure boom is fueled by rapid digitalization, that burgeoning gaming market, and of course, the absolutely insatiable demand of AI.
Yeah, the demand is just incredible.
Yeah. We've unpacked NVIDIA's pivotal, almost monopolistic role in powering this revolution and confronted the immense complexity, the black magic even, and the global interdependence of advanced chip manufacturing.
The fragility of that supply chain is key.
Definitely. And we've explored how Southeast Asia itself isn't just a critical node in these global supply chains, but also a dynamic, increasingly influential player in this intensifying US-China AI competition, balancing those immense opportunities with its own unique regional challenges and skillfully navigating a very complex geopolitical landscape.
I think it's clear, isn't it? The future of AI, and indeed much of our future digital economy, it's not solely being forged in Silicon Valley or Beijing.
Right.
It's increasingly being built, debated, and strategically positioned within this vibrant, incredibly diverse, and strategically critical region of Southeast Asia.
So understanding this region is key to understanding AI's future.
Absolutely. Understanding this region's unique challenges, its fierce drive for innovation, and its intricate position in the global tech landscape is absolutely essential if you really want to grasp where AI is heading next. It's this fascinating interplay of local ambition, complex global supply chains, and high-stakes geopolitical maneuvering. And it's a story that's still very much being written, 1 megawatt, one startup, one policy decision at a time.